Hello dear students. So today we will study the chapter physical quantities and measurement, and this chapter we will study about the density, determination of density of a solid by using measuring cylinder, that is also known as graduate cylinder, and measurement of density of irregular solid using Eureka can, and measurement of density of a liquid by using a density bottle. And we will also study concept of flotation and sinking of a substance and comparison of densities in the three states of matter. So now proceed with the first. So begin with our first topic, density. So let's see here what is density. Definition of density is mass per unit volume of a substance. And density, what is density? Density is mass upon volume. And we shall know what is mass and what is volume. So the amount of matter in a body is mass, means mass determines how heavy or how light a body is. And volume is amount of space occupied by an object or a body, means volume determines how much space a body takes when it is kept in a room or anywhere else. So in this formula of density, mass upon volume, D is density of substance, M is mass of a substance, and V is volume. Let's see here what is the unit of density. So in CGS system, the unit of density is gram per centimeter cube, and in SI system the unit of density is kilogram per meter cube. So see here, there are two blocks, one is iron block and second one is wooden block, and having volume same 1 centimeter cube, means volume of both the block is same, and we know that the mass of iron block will be greater than or will be more than of the wooden block. So here it is clear that the volume is same for the both the blocks, iron block and wooden block. Now mass of iron block will be greater than mass of wooden block, so density of iron is more than of wood. Now we will see conversion of SI unit into CGS unit. Let's see here, 1 kilogram per meter cube, means 1 kilogram upon 1 meter cube. 1 kilogram is equals to 1000 gram and 1 meter cube is equals to 100 centimeter whole cube. 100 centimeter whole cube, what will be equal to? 10 lakh centimeter cube. Now we will cancel 0 0 0 and 0 0 0. What is remaining? 1000. So 1 kilogram per meter cube is equals to 1 upon 1000 gram meter cube, and we can write here 1 kilogram per meter cube is equals to 10 raised to the power minus 3 gram per centimeter cube. Similarly 1 gram per centimeter cube is equals to 10 raised to the power 3 kg per meter cube, or 1000 kilogram per meter cube. Now we will discuss determination of density of a solid by using a measuring cylinder. So in order to determine the density of solid, we must know the mass and volume of a solid. To calculate the mass of solid or to determine the mass of a solid, what will you do? You will measure the mass by or with the help of physical balance. So it will give us the mass of a solid which we have to find its density. After, what will you do? In order to find the volume, take a measuring cylinder or a graduate cylinder. Let's see here how it will be done. There. This is a measuring cylinder, or we can say graduate cylinder. Here there is a markup 20 ml, 40 ml, 60 ml and 80 ml and 100 ml, means this is a 100 ml graduate cylinder or measuring cylinder. So after, to determine the density, we have determined the mass with the help of physical balance. After, we have to find the volume of this solid. So what will you do? First we tie this solid with a fine thread and lower it gently in the measuring cylinder. After lowering it, the liquid level will rise, and record the level. First we have recorded the volume is 50 ml, and after putting the solid, the liquid level rises up to 75 ml. So mass of a solid will be determined by physical balance. Let it will be m gram, and volume of solid will be equal to the rise in the level of water, means initial volume is 50 ml and after putting the solid, the volume raised to the 75 ml. So the raised volume or the raised water level will be the volume of this irregular or this solid. So what will be the volume? 75 minus 50, means final 75 ml and initially 50. So 75 minus 50 centimeter cube is equals to 25 centimeter cube. You also know 1 centimeter cube is equals to 1 milliliter. Let it be 25 centimeter equals to V centimeter cube. So density is equals to mass upon volume. mass is m gram of this solid and volume is V. So density will be m upon V and unit of density will be gram per centimeter cube. So measuring of density of irregular solid using Eureka can. So first we have to see what is Eureka can. A Eureka can consists of an iron vessel which is provided with a spout. Let's see here, this is a Eureka can and this is a spout. So fill the Eureka can with water till the water is point of overflowing. Means we have to fill the water just below the overflowing point. And after that we have to put a measuring cylinder under the spout of Eureka can. Means under the spout of Eureka can we have to put a measuring cylinder. And to determine the density of irregular solid, first we have to calculate the mass of irregular solid with the help of physical balance. After that we have to put the solid gently into the Eureka can, and after putting, the water will flow from the spout and collected in a measuring cylinder, that is measuring cylinder. And we have to record the volume of the solid with the help of record the volume of water overflown. Means the overflown water will be collected in measuring cylinder and we have to record the level, and this will be gives the volume of this stone. After that we know the formula of density. The mass is known from the physical balance and volume is recorded by the measuring cylinder. So we can calculate the density of an irregular solid with the help of formula mass upon volume. Now we will see here measuring of density of a liquid by using density bottle. A specially designed density bottle of capacity 50 ml is used for finding density of liquids. Liquid means other than water, that is kerosene oil, brine solution, alcohol and etc. What is density bottle? It is a small glass bottle having a close fitting ground glass stopper at its neck. Means here is its neck, a glass stopper is put here. The stopper has a small capillary tube. Here is small capillary tube is you can see here, small capillary tube. After we fill some liquid, then stopper is inserted. Then excess liquid rises up through the capillary tube and drains out. Means if there is more liquid or water, it will be drains out, comes out from or discharged through this capillary tube. And it ensures that bottle contains equal volume of liquid when filled with different liquids. Means first we have, means if we are filling with water and then we are filling with kerosene oil, this capillary tube will ensure it will contain equal volume of water and equal volume of any liquid, that is kerosene oil, iodine solution, brine solution, oil, anything. Now, what are the methods to determine the density of a liquid? First, we have to wash the density bottle with distilled water. Then we have to dry it in hot air, and then we have to put insert the glass stopper and measure the empty bottle on a physical balance. This will give a mass of this only empty bottle, means empty bottle mass. After that, we have to fill the density bottle with distilled water completely and then insert the glass stopper. After putting the glass stopper, if there is an excess liquid, it will drains out, and we have to wipe the bottle dry from the outside. Wipe what we have to do, dry the bottle from outside, then measure the bottle which is filled with distilled water on a physical balance and record the mass. Now the third step, pour off the water. Means take out all the water from the density bottle, dry it with the hot air. Now fill with the density bottle with a given liquid, means that is kerosene oil or brine solution, any liquid you can use. After that, we have put the glass stopper. If there is an excess liquid, it will drains out. Now measure the mass of the density bottle which is filled with any liquid. Now record the mass. Now what is the observation here? Let mass of empty bottle is m1 gram and mass of empty bottle plus distilled water is m2 gram, and mass of empty bottle plus liquid is m3 gram, and mass of only water. Suppose we have to find out mass of only water. So how can we find out? Mass of empty bottle plus water is m2 gram and mass of empty bottle is m1 gram. So mass of only water is m2 minus m1 gram. Now we know that 1 gram of water is equals to 1 centimeter cube. So volume of water will be m2 minus m1 centimeter cube. Now volume of bottle is, we know that volume of any container is equal to the volume of liquid or volume of water contained in it. Means if you are carrying 1 liter water bottle to your schools, so its capacity or its volume is 1 liter, or we can say 1000 centimeter cube. 1 liter is equals to 1000 centimeter cube. Now the volume of bottle is m2 minus m1 centimeter cube, and volume of liquid is also the same. So volume of liquid is equals to m2 minus m1 centimeter cube. Now we have to calculate density of liquid. Density is equals to mass upon volume. Mass of liquid m3 minus m1 and volume of liquid m2 minus m1. That gives the density of liquid. Suppose the mass of liquid is 42 gram and volume of liquid is 50 centimeter cube. Then density of liquid will be 42 gram upon 50 centimeter cube. That will be 0.84 gram per centimeter cube. Now we will see the variation of density of liquids and gases with temperature. We know all forms of matter, that is solid, liquid and gaseous, expands on heating and contract on cooling. However, in case of solid, the expansion with the rise in temperature is so small that is negligible, or we can say that is very small. So we can neglect. Since the volume of solid hardly changes, so we can say the density will be hardly changed or it changes negligible. But in case of liquid and gases, the volume changes large or in a greater extent with the rise in temperature. So here in case of solid with minor change in temperature, that is by 20 degrees centigrade to 40 degrees centigrade, then the density of solid does not change. But in case of liquid and gases, there is a large change in volume with rise in temperature, so the density decreases. Let's see here. On heating this liquid, suppose initially its volume is V1. On increasing the temperature, what we have seen here, the volume expands, or we can say liquid expands, that means volume increases, but mass will be remain same. See here, the container is same, the whole mass of this liquid will be remain same, but the volume changes, that is volume increases. And what we can see say that density decreases in case of fluid, that is liquid and gases. Now let's understand with an example. Suppose for any liquid, its mass is 150 gram and at 0 degrees Celsius its volume is 75 centimeter cube, and after increasing its temperature, suppose we have increased its temperature up to 100 degrees centigrade. Suppose at 100 degrees centigrade its volume increase. We all know on heating or rising the temperature for liquid and gases, its volume increases. So at 100 degrees centigrade its volume increase up to 100 centimeter cube. Now we will find the density at 0 degree centigrade, that is mass upon volume. Mass will be same in both the cases, 0 degree and 100 degree centigrade. Mass upon volume, mass will be 150 gram and at 0 degree centigrade the volume is 75 centimeter cube. Now density will be 150 upon 75, 2 gram per centimeter cube. Now in the second case, after rising the temperature at 100 degree centigrade, mass upon volume, mass will be same 150 gram, but for volume increases and it is 100 centimeter cube, means 150 upon 100, that will be equal to 1.5 gram per centimeter cube. So here we can see that at 0 degrees Celsius density is 2 gram per centimeter cube, and after rising the temperature, increasing the temperature at 100 degrees centigrade, the density becomes 1.5 gram per centimeter cube. So we can conclude on increasing the temperature, density decreases. Consequence of change in density in liquids with temperature. When we heat a liquid, say water, in a beaker or any other vessels at our home, then the water close to the bottom of beaker expands. Means after heating, the water close to the bottom of the beaker or to the source of heat, it becomes hot and expands and its density decreases, and the lighter water rise up in the beaker, and to take its place, the cold water from the upper region flows towards the base of the beaker. Thus this process takes place and thus a sort of current set up in water. This current produced in a water is called convection current, and it is the convection current which is responsible for heating a liquid. And it is for the same reason that liquids are heated in a metallic vessel from the below, so that the whole mass of liquid attains the same temperature. Means if we heat from the bottom of the vessel, and after some time, due to the convection current, the whole water attains the same temperature. Means if we put a finger from the upward region, we will feel hot, because due to convection current, the whole water attains the same temperature. Now, consequence of change in density in gases with temperature. Much the same way, the gases get heated up by convection. The air around the source of heat. Suppose there is a burning wood here. What happens here? The wood will burn or coal will burn. The air above this surface will become warm, and after becoming warm, its density will decrease and becomes lighter. It will rise up, and here, after rising up, the cool airs will sink or takes the place of this place, and thus due to this process, a sort of current is produced, and this current is called convection current. It is the convection current in gases which are responsible for the formation of weather, the land and sea breezes, the monsoon, and the westerlies. Westerlies means wind that blows from the west. Now, we can see in our houses the natural ventilation of home is due to convection in gases. Means in our houses the ventilation is provided in upper side of the room, means upward side of the room. What happens in natural ventilation, the warm and less dense air, means the air which is warm or hot is lighter. It rises up and it goes from the ventilators, and to take the place of this air, the cold and dense air from the doors and windows comes to our room, and our rooms becomes cool. Now we will see what is sea breeze. First, it occurs at a daytime, and sea breeze is the wind which blows from the side of sea towards the land during daytime. Now we will see how sea breeze occurs. At the daytime, sun rises and shines equally on the surface of land and surface of sea. The land gets heated up rapidly, means land gets fastly in comparison to sea surface. So the air above the land surface becomes hot or warm, and it becomes less dense, and this less dense air rises up, and causing, after rising the air from this land surface, there is a pressure drop, and to maintain the pressure drop, the cool air from the ocean or sea surface comes towards the land, and this is a sea breeze. Now, what is land breeze? A land breeze occurs at night time, and it is a breeze or wind that blows from the land towards the sea during night. Now we will see what happens in land breeze. At the sunset, means at the night time, sunsets, and sea and land starts cooling. But land cools much faster than the sea water. Means land cools much faster than the sea water. So air above the sea will become warmer, or we can say will be warm. So this warm air having less density, and it rises up. After rises up, there is a pressure drop, and to maintain this pressure drop, the air from the land side will blow towards the sea surface, and this is a land breeze. Now we will discuss relative density. So relative density is the ratio of density of a substance to the density of water. So here the definition of relative density is ratio of density of substance to the density of water is called relative density of substance. And the formula of relative density is density of substance upon density of water, and it is unitless quantity. That means relative density has no unit. Let's understand with an example. The density of gold is 19.3 gram per centimeter cube, and you have to find its relative density. So we know relative density formula, density of gold upon density of water, means density of substance, that we have to find out its relative density, and upon density of water. Density of gold is given 19.3 gram per centimeter cube, and we all know density of water in gram per centimeter cube is 1 gram per centimeter cube, and gram per centimeter cubes cancel gram per centimeter cube. 19.3 upon 1 is equals to 19.3. So the relative density of relative density of gold is 19.3. So now we will see concept of flotation and sinking of a substance. Means we will discuss here which substance or which object will float in water or which subject will sink in water. We all know density of water is 1 gram per centimeter cube, and it is found experimentally that the substance or object having density less than water, that is 1 gram per centimeter cube, float in water, and conversely the substance having density more than water will sink in water. Or we can say for a given liquid other than water, if a solid having density more than the density of that liquid will sink, and if the object having density less than that of liquid will float. Simple rule, the more the density of liquid, the solid will submerge. Let's see with example. So for a given liquid other than water, the given solid will float in the liquid only if the density is less than liquid. Now see the pictures clearly in the given here. It is a wooden block having density 0.68 gram centimeter cube, and there are three liquids. First is alcohol, second is water, and third is glycerin. And the density of glycerin is more than of water, and the density of water is more than of alcohol. In first case, the wood is submerged greater, or we can say it is submerged more, and second case it's submerged less than that of wood but greater than that of glycerin. So we can see that the more the density of liquids, the less the solid will submerge in it. So what happens if any liquid having density less than that of wood, that is suppose any liquid having density 0.5 gram per centimeter cube, which is less than that of density of wood. So what happens? So the wood will sink in that of liquid because the density of liquid is less than that of the body. So the body will sink in that liquid. So we have seen the wood submerged less than glycerin of density 1.25 gram per centimeter cube and submerged maximum in alcohol of density 0.78 gram per centimeter cube. Now the second thing, the change in density of seawater with temperature or due to mixing of fresh water from rivers has serious effect on shipping. Suppose from going seawater we travel, means the ship travel at very large distance, the and comes to the very different geographical location, and the water changes. Suppose somewhere is seawater, somewhere is fresh water, so the density of water also changes place to place. So when a ship is loaded to a maximum capacity, enters a seaport, suppose this is seawater and this is ship, and it loaded to a maximum capacity at seaport, and its condition is like that, means it's submerged very less, and on entering to a fresh water and or we can see any other location, suppose density changes in fresh water and it may submerge more or may sink, and it cause very serious threat or make serious threat to the ship, that cause loss of the goods or destruction of ships and the man on the ship. So for the safety consideration, all ships have marking on their hull. This is the ship and this is the hull to show the level which they should submerge in some particular sea or river. Means it shows the marking in which place or which sea water at which geographical location the ship will submerge at how much level, and this marking is called plimsoll lines. It gives us idea that how much ship will be loaded. Means suppose we are going to a route from Mumbai to Saudi Arabia, and we know that this type of water comes in that route and this type of water comes that route. So hull and plimsoll lines gives us idea to, how much load or how much capacity to be loaded with the ship, so it will not submerge or sink in a particular area. Comparison of densities in the three states of matter. We all know the states of matter, that is solid, liquid and gas. And we also know the arrangement of solid, liquid and gas, means arrangement of molecules in solid, liquid and gas. In solid, the molecules are tightly packed, means in less volume there is large number of molecules. So the density of solid will be greatest in the three states of matter, and in the case of gases the molecules are very far away from each other, means for a same volume the gases have lesser mass, so its density is least, so it is a increasing order of density. Liquid has greater density. Liquid has greater density than that of gas. Solid has the greatest density, and it is more that of liquid and gas. Now let's solve some numerical based on density. Now question is, a piece of lead weighs 232 gram and has a volume of 20 centimeter cube. You have to find the density of that lead. So here mass of lead is given 232 gram, mass is given 232 gram, volume is given 20 centimeter cube. Very easy, we know the formula of density, mass upon volume. Mass is given 232, volume is 20 gram per centimeter cube, and after solving we will get 11.6 gram per centimeter cube. Question 2. 5 liters of alcohol has mass 4 kg. Calculate the density of alcohol in gram per centimeter cube and kilogram per meter cube. Now mass of alcohol is given 4 kg. First we have to calculate in gram per centimeter cube, so we have to convert the mass in gram. Mass is given 4 kilogram, so in gram what will you do? Multiply by 1000 and we will get 4000 gram. Now second, given volume of alcohol. Volume is given 5 liters. We all know that 1 liter is equals to 1000 centimeter cube. So 5 liter is equals to 5000 centimeter cube. So density of alcohol is equals to mass upon volume, 4000 gram upon 5000 centimeter cube. That will give 0.8 gram per centimeter cube. And we also know that when we have to convert the unit gram centimeter cube into kilogram per meter cube, what we do? We will multiply by 1000. So density in kilogram per meter cube is, we multiply by 1000. So 1000 into 0.8, that gives 8000 kilogram per meter cube. Now the next question is, you have to find out the mass of 555 centimeter cube of iron in kilogram when density of iron is given 7.6 gram per centimeter cube. Here density is given in gram per centimeter cube and mass is given in mass we have to find out, and volume is given 555. Now volume is 555 centimeter cube, density is given. We know the formula, density is equals to mass upon volume, and we have to calculate mass. So mass will be, volume will multiply by density, mass equals to density into volume. Density is given 7.6, volume is given 555. We multiply 7.6 into 555, that gives 4218 gram. And we all know that how to convert gram into kilogram. We have to divide by 1000, so we get 4.218 kilogram. Now the next question. A density bottle weighs 20.25 gram when empty, means mass of empty density bottle is 20.25, and 40.75 gram when filled with liquid, means mass and 50.25 gram when filled with water. That is, mass of density bottle plus liquid is 40.75 and mass of density bottle plus water, means when it is filled with water, that mass is 50.25. So first we have to calculate mass of only water. So mass of only water is, mass of bottle plus water is 50.25 and mass of empty bottle is 20.25. What we have to do? Subtract 50.25 and 22.25. That will give 30 gram. That is mass of only water. After that, we know 1 gram of water is equals to 1 centimeter cube. So 30 gram equals to 30 centimeter cube. Now, volume of water is volume of only water, that is 30. We have discussed that volume of any container is volume of water contained in that container. So volume of water will also equals to 30 centimeter cube. Now mass of only liquid. Mass of liquid plus empty bottle is 40.75 and mass of only bottle, that is empty bottle, that is 20.25. So subtract 20.25 from 40.75, we will get 20.5 gram. 20.5 gram. Now to calculate density of liquid, we have the formula mass and mass upon volume. Mass of liquid is 20.5 and volume of liquid, that is volume of container, that is 30 centimeter cube. That gives us 0.683 gram per centimeter cube. That's all about physical quantities and measurement. So thank you everyone. Stay safe and take care. Thank you.